The next few exercises involve tangent lines to curves at some given points. So actually there are 4 exercises here and I am doing one of them, namely number 50. Graph the curve over the given interval. So a curve is given to you, an equation is given to you, so corresponding to it there will be a curve, but over the given interval, not the entire curve, together with its tangents at the given values of x, and here those values are minus pi, 0 and 3 pi over 2, and the interval is from minus 3 pi over 2 to 2 pi. Now how will you graph this? Of course it's impractical to draw the graph on graph paper. I mean, you can do if you want, but there are better ways of studying these things. And I have said this many times before and I will keep on saying this. This is a great site, Desmos Graphing Calculator. You visit this site and there you will see, this is how the screen will look. On this side, you have places for writing the equations. You can graph multiple equations simultaneously, and on this side the graphs will appear. Now normally if you just simply want to graph y equal to sin x, you just type y equal to sin x here and the graph will instantly appear on this side. However, if you want to draw the graph in a restricted way, for example in an interval, then you instead type this in. Okay, so you use curly brackets here and then you write the interval minus 3 pi divided by 2 less than or equal to x less than or equal to 2 pi, and then put colon, and then you write what the function itself is, sin x, you close the bracket, and then only that portion of the graph will appear which lies in this interval. So you can try this, it's very fun, and in fact learning calculus without a graphing calculator is almost pointless. So what are we going to do here? Of course I am not going to draw a graph here, but instead what I will do is I will find equations for the tangents at these given points to the curve. So let's see the tangents now. So first we find the equation of the tangent at the point x equal to minus pi. The tangent at x equal to minus pi has this equation. You already know how to write the equation of a tangent to a curve at a given point. Because the tangent is supposed to pass through that point, you can use that point to write the point slope equation of the tangent, whose form you already know. If the point has coordinates say a comma b, then the equation is y minus b equals the slope times x minus a. In this case, our a is minus pi, and what is b? B is the value of the function at minus pi. So we write y minus y of minus pi. So this is the value of our function at minus pi, which equals the slope of the curve at x equal to minus pi, which of course is the value of the derivative of this function at minus pi. So y prime of minus pi times x minus a, that is x minus minus pi. Now what do you get if you evaluate sine at minus pi? The sine value of any integer multiple of pi is 0. So sine of minus pi is also 0. What is the derivative of sine x? Cos x. And what do you get if you evaluate cos x at minus pi? Cosine of minus pi is cosine of pi, because cosine is an even function, and cosine of pi is minus 1. So that's why we have a minus 1 here. And this one of course is x plus pi. Now this is minus of x plus pi. So if you bring it to this side, it becomes x plus pi. So the equation is x plus pi equal to 0. Now what you can do, now on Desmos, You of course draw this graph of sin x in that interval. And how will you locate the point? So below the equation of the graph, you just write minus pi comma 0 within round brackets with a comma, like how you write the coordinates of a point. You will see that the point will instantly appear where it has to appear on the graph. And then below that you type in this equation and you will see that it is the tangent to the graph at that point. I am showing like this because that's how it really appears. I saw today. So that is one tangent and we have to see two more. So let's see next for the point x equal to 0. The tangent at x equal to 0 has this equation like the previous one. Y minus y of 0 equals y prime of 0 times x minus 0. If you evaluate sine at 0, again you get 0. Like sine pi is 0, sine 0 is also 0. And the derivative is cos x, cos 0 is 1 times x. So the tangent here is this line, y equal to x, that line. So the point here is actually the origin, and it makes sense also because the sine curve passes through the origin, and at the origin this line is the tangent to the curve. And next we go for this point, 3 pi over 2. At x equal to 3 pi over 2, this is the equation of the tangent. Now what is the value of the function sine at 3 pi over 2? It is minus 1. You can go back to the definition of sine and see why it is minus 1. So as you traverse the unit circle and in anticlockwise sense, so you start from the positive x-axis, and when you are rotating like this, and when you reach the positive y-axis, then your sine value is 1. So that is pi over 2, the angle. Then you go another pi over 2. So you reach the negative x-axis, and there sine becomes 0. So you see pi over 2, pi over 2. So that means the angle now is pi, and at pi we know sine is 0. So that is why it is 0. And another pi over 2. So now it goes below the x-axis, and there the y coordinate of that point is minus 1. So that is the sine value. So this one is minus 1. And the derivative of sine x is cos x, and the cos value of 3 pi over 2 is equal to 0, because cosine vanishes at odd integer multiples of pi divided by 2, and this is one such number. So this is 0 times x minus 3 pi over 2. So the tangent here is y equal to minus 1. Actually you can already see why that is the case. That is because at this point x equal to 3 pi over 2, our sine function takes the minimum value. So there is a valley. The graph comes like this, then attains its minimum value, then again goes up. So obviously the tangent there, geometrically it makes sense. The tangent there should be horizontal, and you are getting a horizontal tangent. So this is the tangent at that point. Let us see another problem next. So next we have some problems from which I am going to solve two. Let's solve this one, 54. What do we have to do here? Do the following graphs have any horizontal tangents in this interval between 0 and 2 pi? If so, where are these tangents? At which point are such horizontal tangents there? And if not, why not? So let us see what happens in this case. You already know what we have to do for horizontal tangent. We first differentiate the function, and wherever the derivative becomes 0, those will be the points at which we will have horizontal tangents, if any. So differentiating 2x plus sin x, we get this. Differentiating 2x, we get 2, and the derivative of sin x is cos x. This, however, is never 0. Why? Because this is 0 precisely when cos x is equal to minus 2. But we already know that any cosine value, the cosine value of any real number x is always between minus 1 and 1. So no possibility of ever having cos x equal to minus 2, no matter what real number x you choose. So that is why the derivative is non-zero, and so there is no horizontal tangent. In this interval, actually it's not present anywhere. If you draw the graph of this on Desmos, the graph looks like this. I mean, there is no point on the graph where it becomes horizontal. It kind of goes higher and higher, like there is a wave, I mean there is a wavy nature to this, but it goes like this. Okay, no horizontal tangent. So this one fails to have any horizontal tangent. Let's see another one. The next one is, say, this 56th one, y equals x plus 2 cos x. So in this solution, again of course, we differentiate the function. So differentiating x, we get 1, and differentiating cos x, we get minus sin x. So that's why minus 2 sin x. This time, however, we cannot immediately say that this won't ever be 0. It is equal to 0 if and only if 1 minus 2 sin x is 0, if and only if sin x is 1 divided by 2. And now there are values of x at which this will happen. One of those values is pi divided by 6 radian, or 30 degrees. So now you recall from your school knowledge of trigonometry, of solving trigonometric equations, how to write the general solution of this equation. The general solution looks like this: n pi plus minus 1 to the power n times pi divided by 6. Actually, I should have written one more thing, where n belongs to z, the set of integers. So as you vary n over the set of integers, you are going to get infinitely many different values of x. At all such values, the sign value will be equal to 1 divided by 2. But now, what is it that we have to do? We want to find those values that lie in this interval. How can we do this? Let us see. Because of the nature of this general expression, that is, because it involves minus 1 to the power n, and which depends on, it becomes plus 1 or minus 1 depending on the parity of n, whether it's even or odd. So let us first consider the case where n is even. Then n is of the form 2m, where n is some integer. Now we want such values which lie between 0 and 2 pi in this manner. So what will happen to this power of minus 1? Because n is even, so it will become plus 1. So we have pi over 6 here, and we have written 2m in place of n. Now next what we do, we multiply throughout by 6 divided by pi, and by doing so the inequalities won't get reversed, because 6 divided by pi is a positive real number. So this will become 12m, this will become 1, and this will become 12. If it sounds a little difficult at once to multiply by 6 divided by pi, you can do it in 2 steps. You first divide throughout by pi, so that will just simply make all the pi's vanish, and then you can multiply by 6. You will get this. Now subtract 1 from all the terms. So that gives you minus 1 less than or equal to 12m less than or equal to 11. and then divide by 12. So that gives you this. And now the fact is that m is an integer, and in this range there is only one integer, and that is 0. So that can be the only value of m in this given case. And what happens when m is 0? Then n is also equal to 0. 0 is an even integer. So what exact value are you getting for the choice n equal to 0? When n is 0, this part of course it vanishes, and this becomes plus pi over 6. So pi divided by 6 is one of the desired values in that interval between 0 and 2 pi, at which our function will have a horizontal tangent. But next, let us also see what happens when n is odd. If n is odd, then n is of this form 2m plus 1, where m is some integer. So this time these inequalities are equivalent to, so what will happen now? In place of m you are writing 2m plus 1, and because n is odd, this becomes minus 1. So we have minus pi over 6, and then again multiply throughout by 6 divided by pi. So that gives you this. This becomes, divided by pi means this pi gets cancelled, and actually we are multiplying this 2m plus 1 by 6. So we get 12m plus 6, and this one becomes minus 1, and 6 divided by pi means this becomes 12. So 6 minus 1 is 5. Now you subtract 5 from all the three terms. So that way you get minus 5 less than or equal to 12m less than or equal to 12 minus 5, that is 7. And then you divide by 12. So that way you get this. Oh, and let me just draw your attention to one more thing. We are not writing simple implication. We are writing if and only if. So whatever you are doing, you should know that you can go back. Okay. If these inequalities are true, then m is like this. And conversely, if m is like this, then these inequalities are true. So that if this is what you have got, you don't have to then go back and put the values of m that you are getting finally from here and see if these inequalities are true. Because you also have reverse implication, yes, they are true. Now here also the only possible value of m, because m is an integer, is 0. So when m is 0, then n this time is 1. And if you put n equal to 1 here, what are you getting? Pi minus pi divided by 6, or 5 pi divided by 6. So this is another value of x in that interval between 0 and 2 pi, at which the graph will have a horizontal tangent. I want you to go and see on Desmos. You find the tangents, find the equations of the tangents, plot the graph, plot these points which you have found here, and plot the, not plot the tangents, you write the equations of the tangents so that you will also get their graphs. You see if they really are horizontal tangents. You will see that the graph at these 2 points, at one of the points it has a peak, and at another point it has a valley. So at these 2 points obviously there will be horizontal tangents, so that you can check on Desmos. And let me just end this video here itself. After this exercise, there are others, okay, that you have to solve, which are similar to these things. After this, there are other exercises which involve simple harmonic motion. So that we will do next week. So see you next week with those things. Until then, this is me, Lucifer, from a mathematical room. Have a nice day.